Okay. So last time I showed you this picture, correct? From this picture, you know how to do the derivation for momentum balance. Where's the sign-up sheet? Okay, sign your name. You two forget, I checked already. That's fine. I checked your name already. So stratified flow look like this. Alright? What I really want you to do, to be able to do, at least today, is go from this picture and get equation 3.28. Okay? Without any book or any reference material. Tomitope, can you do it?
No.
Oh, you don't know? Maybe, right? Maybe. So let me repeat myself several more times. First, you have to be able to draw the picture. Can you draw the picture? Okay, you draw the picture. That's easy, right? Can you do this? Can you draw that? Tau W, can you draw that? Today, I don't know if I want to have a quiz or not, but I bring this. It is an empty page paper, enough for all of you. Did you bring pen? You don't need calculator if we have quiz. So it is a pop quiz. I will have it when I tell you to have it. Okay. So make sure that you can draw this picture. Can you draw this picture? The top part is tau WG. Memorize it. Memorize. There's a time to memorize it. Writing it down may not do much if we have the quiz today. Memorize it. So you see this tau WG? You can write it down, right? You can write this picture for gas phase. Can you? Right hand side is positive. So left has P and this one is P plus delta P. It is important to the point where I want you to memorize it. Okay? And this picture, tau I, so the important thing is, if your tau I go this direction for gas, tau I for liquid should be opposite direction. Can you memorize it now? I can. Yes, of course, why not, right? Okay, Akin, you already know that the unit of tau is Pascal, force per unit area. And you can do force balance, right? You can do this. Can you? Yes. Oh, what kind of work do you need to do on it? You have to do force balance. Force is pressure multiplied by area. So for tau I, what kind of area? Area at the interface. SI delta L, right? That is for tau I. What about tau wall? For liquid part. So it will be SL delta L, tau WL. That is a force. Shear force, right? What about pressure? What kind of area? Cross-section area, right? Cross-section area occupied by liquid. If we do force balance for liquid. If we do force balance for gas, there will be cross-section area for gas. You will have to do on the new paper, okay? You have to do on the new paper. So if you write it down now, it's fine. But when we do the test, if we ever do the test, it will be on the clean paper. Hand it to you, and then you do the derivation. Yes.
Why don't we have friction between the liquid and the pipe?
Oh, do we have friction between liquid and pipe? Maya?
Yes.
Which term? How about that term? Good? So we have friction between liquid and pipe. Tau W is a friction between liquid and pipe. Okay? Tau is a kind of pressure, shear stress force per unit area multiplied by area, then that's kind of friction force, right? And we have friction between liquid and gas. Tau I is a force per unit area, right? So you do force balance. Okay, force balance, and you don't have to do all direction, you just have to do x direction, right? For the x direction, the force that go to the right hand side equal to the force that go to the left hand side, just that. Or the force to the right minus the force to the left equal to 0. Okay. So sigma f equal to 0. So it's not like ma, it's no acceleration or anything like that. We neglect the acceleration term. We assume steady state. So you don't worry about the term that change with time. So force to the right for liquid part is tau I multiplied by Si delta L. That's one of them. Another one is pressure, right, multiplied by AL. AL is the pipe area covered by liquid phase. And another part, the force to the right hand side is O. It's just that, right? So now let's take a look at the force to the left hand side. Force to the left hand side is P plus delta P and rho G sine theta. That one, right? And tau WL. So we have three of them. So what do? I have right hand side tau I multiplied by Si delta L plus force to the right hand side P AL, right? Force to the left hand side is minus P plus dP AL. Right? That's force to the left hand side. Minus tau WI SL delta L. SL is a curve on the bottom. So we have, and gravity term, rho G sine theta. Rho G sine theta multiplied by AL. Right? So I show you here that rho times AL times delta L, that is liquid mass in the control volume. That is the liquid mass in the control volume. So liquid mass multiplied by acceleration in the minus x, which is g sine theta. So we get this one, A delta L rho L g sine theta. Combine all of them together, we get that. Good? Okay. Good? Yes, right? Yahweh, is this good for you? What about gas phase? We do the same thing for gas. Right? You write down each term. The difference between gas and liquid. Look at, you just change from AL to AG. If you draw the picture, if you draw these two pictures, you get the equation for liquid done, and you said similarly, then you pop up with this equation. It's fine for me. What you have to change is minus stay the same, right? Just change AL to AG. So this term minus tau WL, you get minus tau WG, right? Change SL to SG, correct? The part that is different is tau I, because with respect to its own control volume, for gas, tau I move backward, but for liquid, tau I move forward. So that's why we have positive here, but negative there. Okay? And this term is the same, rho G sine theta. Of course, you have delta L for each term and you divided that for all of that. So if you look, this one look like this. Just change A rho L to rho G, AL to AG, sine theta. We know that this term is the same as that term. Divide everything by, for gas, divided by AG, for liquid, divided by AL, subtract it. Then we get that equation. Dimensional form of combined momentum equation. V12, are you ready? To derive this. You ready, V12? What about Nhan? Raymond, are you ready? Yes. Wow, okay. So Arya, how much more time do you need to read this to be able to ready? You can do it right now. Tolani? Do you need more time? What? You just have to start from close book, close everything, start from writing this kind of picture. You may just write this one, okay, and do that. You good? Okay. Vanguard, what do you say? You good?
Yes, sir.
Okay. Let me give you paper. Close book. Okay, what we will do is close the book. Sit.
Are you serious?
Oh yes. Sit. Have one empty seat between you and another person. Okay. You can do it, right? Don't write anything yet. I will wait another 1 minute for you to read it. Yeah. Close the book. Close the book. Close the book. Or you can read it, but read it for now. Keep reading it until you find it. One for her. What are your name? Oh, no, don't write anything on this paper, okay? Don't write anything on this paper. Just your name.
No, it's not your paper. It's my paper.
Okay, which one is my paper?
Here, no.
Alright, what about this? Don't write anything on my paper yet. Write just your name. Write just your name. It's not that difficult, okay? Let's go through it one last time. Anyone have a problem with writing this picture?
Yes, it's so stressful.
I'm not. You have the problem with writing this picture? Who say yes? Tomitope, what is your question?
I'm not trying to understand it, so it's taking some time to process.
Tau move in the opposite direction. You have a lot of time. You have 2 nights to process this already. Tau WG move in the opposite direction. So first you write a box, okay, of gas. You write this. You write that. You write that. You write that. Very easy. You don't even need to write this, okay? Force. This force multiplied by S what? Sg delta L. Okay. The middle one, tau I is Si delta L. Tomitope, are you good? More question for me? Okay. Tau I has to multiply by Si and delta L. So it is this area. Maya, did you just write your name?
But also we have
Oh,
101.
oh yes.
Oh, that's stressful.
Okay, I just tell you that force, pressure or shear stress multiplied by area is force. Force to the right direction is positive, force to the left direction is negative. Add them together, equal to 0. Do it for gas, do it for liquid, subtract them. Just that. Okay, close your book. Alright, put your book away. Maya, what do you have in your paper? What's that?
I'm not looking at this.
You have the one of them, okay?
Looks like
That's yours. Are you ready? No stress, right? Doesn't seem like you guys stressed, right? You're fine. One constant between you and your neighbor. Okay? Separate a little bit more. So you see the final form, right? This is what you should get. Okay. I will stay at this page. Okay, once you're ready, the instruction is derive combined momentum equation, which is that one. Okay, go. 10 minutes, okay? 10 minutes. So 10 minutes. Your time will end at 11:29. No, you don't show any of that. It's easy now.
Who's the command here?
Pencil. It doesn't matter. Use your pen.